Okay, so good morning, ladies and gentlemen. I'm sorry that my presentation is in English. I'll do my best to keep on time as well, and thank you very much for inviting us to speak here today. So I'm talking today about a specific application for PET, which is hot-filled products, which therefore require no preservatives. So the topics I'd like to look at today, we're just going to give a quick introduction to my company. We'll look at what hot fill is and pasteurization process, the container filling process which is required, and then the advantages of the method that we at ASB use, which is called double blow. We'll take a look at the container molding process and then a very quick look at some of the machinery which performs this process. So very quickly about my company, we're from Japan. We were formed in 1978. We have factories now in 2 countries with 19 sales subsidiaries, plus 40 agents around the world. And we have machine sales in over 129 countries. Our main business is one-step injection stretch blow molding machines, but today's topic is about a process called double blow heat set molding. ASB has been present in Turkey almost since the beginning of PET, over 35 years. Over 280 machines have been sold, 350 mold sets. Although we're a Japanese company, we have local representation here in Istanbul with Erensoy Limited, and also technical cover and sales from Düsseldorf in Germany. So, first question is hot filling. What is it for? Why do we need it? Well, the purpose here is pasteurization, which is often used with many products to kill bacteria, which may cause tainting. And decontamination can be enhanced by additional pasteurization after filling into the container. So both of these processes require a container that has heat resistance. No problem, of course, for glass, but for PET, we have to do some special processing. And hot filling has got an advantage in that it also ensures that the container itself and the cap are also sterilized at the time of filling. There are no additional precautions necessary. Hot filling can also aid with the filling of high viscosity products, such as ketchups, sauces, jams, etc. Now, hot-filled PET bottles have been around a long time, but only in the last couple of years have we been introducing PET jars to the market for hot fill. So the range of products which can go into hot fill is enormous. This is juices, teas, ketchups, which are in bottles already. Products which are in glass currently, such as pickles, jams and marmalades, sauces and condiments, purees, curries, sauces, and of course some Turkish specialities, especially tomato paste. And already, as far as hot fill jars are concerned, there are some products on the market already, especially pickles in Europe. And these products, sauces already in the market in Turkey in hot fill bottles. So, as I said, heat-resistant PET bottles have been around a long time, but many people have sometimes been put off by going to a hot fill bottle because traditionally they've been heavier than standard bottles. But with developments over the last few years, we've managed to lightweight the bottles and also improve the diversity of design. We're not fixed into one design type. And as far as the neck is concerned, sometimes it may be amorphous, that's a clear neck, and sometimes it may be crystallized, and that's where you see a white neck. That depends on the container specification, the type of food to be filled, etc. So I'll explain more detail about that. Hot fill jars, on the other hand, are much more difficult because the size of the neck means that it's much more sensitive to distortion, so the difficulty increases exponentially. Also, on top of that, we have industry standard metal lug caps which put further strain on the neck. But with the improvements that we've made, we've managed to succeed and get PET jars onto the market for hot fill. And the reason why we've persisted is because, as far as our figures show, in Western Europe alone, in excess of 5 billion jars a year are hot filled. Currently, of course, in glass, but we intend to take some of that business. So the first thing we need to look at is the container filling process to understand what's special about the container. There are basically 4 categories of hot filling. The first one is hot fill plus forced or natural cooling after the filling. Second one, we may hot fill and then provide further pasteurization in the container, then go on to cooling. We may even, depending on the product, fill cool and then heat up in the container with pasteurization and then cool. And in some cases, a pressure-balanced autoclave may be required to equalize the pressure on the inside and outside of the container. This is just some typical methods which are used. Just try and find the laser. Starting here on the left, we have the empty container which we rinsed. It will be hot filled. It may or may not be flashed with steam. This provides extra sterilization, but also rapid cooling of the steam helps to create a vacuum at the capping phase, which is very critical. What happens to it after that depends on the nature of the product, pH values, viscosities, etc. It may be naturally cooled, it may be force cooled, or it may go through additional pasteurization. Just to show some examples, I mean, this is an apple sauce. Both are apple sauce, both are in Japan. Just the difference is 2 different companies. And one company, they are providing pasteurization at 92 degrees C for 5 minutes. The second example, 95 degrees C for 3 minutes, then an additional 90 degrees C for 23 minutes before cooling. So same product, but a wide, very diverse set of filling characteristics. European pickles, which are already on the market, are actually going through this process, which involves a autoclave, where the pressure is balanced on the outside of the container during pasteurization. And the entire process of filling and pasteurization, which is also part cooking the vegetable inside the jar, takes 75 minutes. And then they go on to full cooling. Here are some examples of the type of temperature profile we may see. On the left, we hold at high temperature for a few minutes, then immediately start cooling. On the right here, the product is filled much cooler at around 70 degrees C, and then is actually heated up and held at 80 degrees C for 10 minutes before cooling starts. And again, it just depends on the food stuff which is going into the container. Another consideration is with high viscosity. Okay, we can improve the flow of high viscosity with hot fill, but we also have to be aware that high viscosity materials or products do not generate convection currents within the container. So the pasteurization process has to be increased to ensure that all of the product is pasteurized during the filling process. So as a combination of this, the design of the container and heat resistance that's required will depend on many, many factors. Of course, we have the shape or the brand image that the customer is looking for, things like weight and molding conditions, but then the food product itself is driving the design and the specification of the container itself. Now, at ASB, what we tend to do is we have made jars which pass virtually every hot fill scenario that we can think of, but we don't want to have the customer to have an inefficient process, so that once we know what he wants to fill, how he wants to fill it, we will then optimize the design, the weight of the container to suit the product that he wants to fill. So I mentioned that our process is called double blow, so I just want to explain the advantages of that and how it's different to other forms of blow molding. In double blow, we use a 2-step blowing system. This is not the same as 2-stage PET stretch blow molding. What we're doing here is blowing once and blowing a second time. And by doing that at high temperature, it allows us to get high crystallinity in the PET and high density, which allows 90 to 95 degrees C heat resistance using standard PET resins. And that's one of the key points about this. We don't need to use anything special in terms of material. This allows us also greater diversity of container designs, bottles and wide-mouth jars, and it also allows a longer storage life for the container, both before filling and after filling. Now, gas barrier is always an issue. People want to have oxygen-sensitive products filled, and one of the side effects of double-blow system is that the natural gas barrier of PET will be increased by around 30%. This often will be enough for the product being filled without any special steps to be taken. But if you have a more sensitive product which needs more oxygen barrier or more moisture barrier, for example, you can use oxygen scavengers or other barrier materials or plasma coating. Anything which is being applied to containers at the moment can also be applied to these hot fill containers. And just to show some of the actual performance data, if we look at the standard blown container, the crystallinity of the material is about 1.36. A single blow heat set raises it, but double blow raises it even further. And it's this enhanced density, or crystallinity and density, which helps the container to give this performance. If we look at the gas barrier, the effect then is going from 1, we go up very moderately for single blow, but we go up about 30% for double blow. And what that means is that if you have a current shelf life target of, say, 6 months, you will extend that by an additional 2 months. Or if your shelf life target is 1 year, you've increased it by 4 months without any special processing or additive into the material. Just the double blow process is achieving that. This is just some data that supports that. We see the single blow here creates a very modest increase in gas barrier, but the double blow brings us right up to about 1.3. So looking at all the advantages of double blow over various alternatives, the higher temperature resistance that we get allows us to go up to 95 degrees C with standard materials. And when you're doing hot filling as opposed to aseptic filling, the process of filling is very simple. All you have to do is monitor the temperature, and you know that your product is safe. With aseptic, there's a whole range of bacteria cultures to be taken and studied, and you have to hold your stock until you know that it's clear. Hot filling is much more simple. And what that means is that your investment costs, your training, your operation, all these costs are dramatically reduced. And also in hot filling, naturally that the product is going to cool after filling, and that creates vacuum in the product. And as soon as you open the product, you can feel the container relax. And this tells the consumer that this container has not been tampered with. It's come from the original filling factory without anybody tampering with it. So consumer confidence can be increased. Now, of course, I don't need to tell you maybe that the advantages over glass are very easy to understand, but just to give an example, a 950 milliliter glass jar weighs 375 grams. A hot fill jar for PET of same size is just 17% of that weight. And that means, of course, volume reduction in storage and transportation, less breakage, less contamination. We don't have to run the risk of glass particles being in the food product because of a broken container. We've heard from other people earlier on that recycling becomes much easier, and of course carbon emissions in manufacturing and transport are all better. But sometimes people are not just changing from glass to PET, they're changing from other plastics into PET. And this is one example which we did. This is actually pickled onions, which previously were in extrusion blow molded polypropylene multi-layer container. And the image quality improvement is dramatic to see, but also because it's not multi-layer, we've got improved recyclability of the finished container, which I think will make some of our members of the ministry happy, I hope. Okay, so that's so much for the filling process. Look at how the containers are made, because there is a special process here. The challenges we face is that heat will always soften the PET material. In the neck, that will cause distortion as soon as we put the cap on. In the body, the material itself is trying to shrink back to its original form, and vacuum that's generated inside the container will lead to distortion and collapse of the container. So we have to fight against these things. Now, the basic properties of PET are like this. Amorphous is clear and tough. Crystalline has got low stress and a high softening point. These are mutually exclusive. The material is normally either amorphous or crystalline. What we have to do is combine two sets of characteristics into one container. So the solution. During the molding process, we have to modify the crystal structure of the PET. Now, in the neck, in some cases, you don't need to do anything with the neck. If it's a relatively low temperature fill, a plastic cap, a strong neck, you can sometimes just use a thicker neck and keep it amorphous. But generally, a crystallized neck, especially for the jars, will be absolutely necessary. In the body, well, we need to have good heat resistance, and that means creating crystals. But if we create too many crystals, we achieve hazy appearance. It's not clear. So we still need to keep the clarity, but also get the heat resistance. So the process is very simple. We're going to use a preform molding machine to mold the preform initially. In the case of crystallized necks, the neck of the preform needs to be slightly larger because it's going to shrink. Or in the case of non-crystallized necks, the neck anyway neck needs to be modified. If neck crystallization is necessary, the preform is passed to what we call a CM series machine, where just the neck part is heated, and the result will be preforms that look like this. Now, as I said, the need for crystallization in the neck is variable. If we're talking about bottles, then there's several factors here which will dictate yes, no, if the neck can be amorphous or needs to be crystallized. However, for for jars, always we say yes, we need to have the crystallized neck because the size would be too difficult to manage against distortion. Now, once the container is, we have the preform, we now pass it to the blowing machine where we provide normal heat, reheating, and then we blow the preform into a very hot blow mold. This is around 180 degrees C. So we inflate the preform, and then we release the air, and immediately this container is going to start shrinking, but also crystals are growing in the material. We then pass it to the final blow mold where the final shape is made, and this is also running hot, around 95 degrees C. And the final result is the container is produced with low stress, good clarity, and up to 95 degrees C heat resistance. This is just an overview showing the various steps which we just talked about. The preform directly from molding, after crystallization of the neck. This is after the first blow, the final blow, and this is with the cap. Now, people ask us what PET resin, I said that we can use standard resins. Well, we can. However, we tend to recommend a particular resin because it ticks all the necessary boxes. Especially on price and availability, Far Eastern Textiles CB651 is the grade which we would recommend to most of our customers. So I've got just a little 2-minute video here which I'd like to show the neck crystallization process and the blowing process. The neck crystallization is done with a CM series machine. This is a 6000 M, so that's processing 6,000 preforms per hour. And this is simply using heaters to heat just the neck portion, and you can see the crystallization of the neck there. The preforms are then passed to the blowing machine, And again, this model is an HSB 6M. This preform is a 63mm neck. And this is a reheat blow machine. But once we get to the blowing, we see a dramatic difference from normal machines. Here we have the preforms being transferred and ready for blowing. Then the preforms are passed into the first blow mold, and as the blow mold opens, it's actually possible to see that the container has shrunk back, because remember, this blow mold is running at 180 degrees C. That partially blown container with its partial crystallization is then passed to the second blow mold, and the final shape is blown at a mold temperature of 95 degrees C. So very briefly, just to finish off, the type of machinery that's available for this molding. We have a range of machines where we're expanding the range all the time. We already have 63mm necks on the market for jar. 82mm has already been tested, and currently 110mm is at the advanced trial stage, ready to come to market very soon. That container would look something like this. This is, in this case, a 4-litre container, 179 grams, molded by our HSB2M machine. And the machine layout looks something like this. We have a preform unscrambler feeding the preforms in, reheating round here, and then the first blow and the second blow and eject. Now, I said we mold preforms first. We have the PM series machines. We have a range of machines with different cavitations which are dedicated to jar preforms, but we can also mold bottle preforms on these as well. We have currently 4 CM series machines of different neck size capacities and output capacities. And we have a range of HSB series. There's 4 machines with 5 different molding configurations currently. There we have some samples here today. My colleague, a local colleague, Mr. Erensoy, who's on your right, if anybody's interested to talk to him about samples and more information. If you'd like to get a copy of this presentation, please talk to me afterwards or Mr. Erensoy. We can help you out. Just very last point, the typical output at the moment for bottles between 2,500 and 6,000 bottles per hour, and for jars from 1,400 up to 5,400. As I said, if the market demands, we will expand the range of machines, but this is what's currently available. So, thank you very much for your time.